Hello guys, good morning. Welcome to Ben's blog. Now we're going to talk about AVR again, but this one is the AVR of Meccalte alternator. These are AVR. So if you are familiar with this kind of AVR, then let's comment down below so we can talk about it. So if you have some doubts also and you have some questions, just comment down to our YT so I can reply to you if I know the answer. So once again, let's start to our vlogs today. So hello guys, now we're going to start our topic. This one is the Meccalte AVR, which is what we call it here as DSR digital regulator. So let's jump up to our technical informations about this kind of AVR. So let's talk about all here about technical. We don't go more deeper about the explanations for this, and only we need to know is the technicality and the usage of this kind of AVR. This AVR also can be used as in the paralleling or a synchronizing AVR. So let's go to the specifications of this AVR. So around here it is stated that here is the main characteristics of this AVR. So this AVR is architecture of the system. So this is oh my god, what happened to me? The DSR is voltage regulator for synchronous alternator, so it's well applicable for the synchronizing. So it is designed to stand alone working and calibrations to the maximized performance. The regulator should be understood as a part of the systems made of at least 3 components. Okay, so we have their own 3 components for this, and this is, I will show you later on for this component, but for now I don't have, I have only here for our the communications for the laptop, which is you can connect to the USB directly to the AVR. So they have their own corresponding product for that one. So for the AVR, so here let's continue for that one. So these are control units is communications module or USB to the XR. So I think this is the one, this one for the communications. So I think this is the for your communications USB to your AVR. So you just need this cable in order to communicate for that directly. For example, this one here, this is our AVR, this is the DSR AVR. So in the edge of this one, you can see it here. You just connect this one directly to this side like that, and then you have to connect also and the end of this one to this side, so in order to communicate through your laptop. So just like that, end to end is that the connections for that, and the rest of that is the USB. So let's see, this is the USB. For example, you just connect this one here and to your laptop. So you just need the some what was that, for converting to 2.0. okay, so I just want to show you the connections for that. So I just want to remove it back. Okay, so because this one is new, I just want to put it back in the plastic bag over here. So okay, let's go back to our continuations. So this appropriations is made up of personal computers and another synoptic device, or both are DOS. The optionals does not have the functions of controller systems in real time, but allows programming and visualizations of all operations parameters for DSR. So here this one is only for the monitoring. You can adjust, but it is not if you once you remove or once you're done, it is not safe. It will go back to the original calibration. So you just monitor and you just little adjust whatever you need to do, but it will not save. Okay, so this is good for the monitoring only, as stated here. And it is equipped with USB interface and its connections. It is possible to use the communication module to USB 2D XR. So no need for that one. So let's go directly to our technical characteristics of this device onboard generator. Okay, so here it's stated that the full digital control regulators based on DSP. So onboard mechanism installation suitable for all self-regulated alternator. So it's like all self-regulated means that is like shunt alternator or AVR. So here this voltage you can apply for 40 VSC to 70 VSC from auxiliary winding, and for your PMG. So this is the range for the voltage you can use for this kind of AVR. So here's the frequency is range also to 12 Hertz to 72 Hertz. Okay, so the sensing voltage within through RMS is average measurement to 72 to 80 volt AC. The maximum continuous output current is 5 ADC. So this is the maximum current drawn from this AVR. For the excitations is only 5 amps. Okay, so precision voltage regulations is 1% from no load, terminal load, and static conditions with any power factors and frequency variations ranging from -5% to +20% of the nominal value. Okay, so next is precision voltage regulations, ±1% from the load to minimal load, static conditions with any power factors, and for frequency variations ranging to -5 to +20% from your nominal. Okay, so voltage recovery time within ±3% of the value set, less than 300 milliseconds. Okay, it's okay, passed already. So transient voltage during startup is less than 5% of your nominal voltage. So for example, you have the nominals up to 20, you have the nominals of 400, 380, 440, that is your nominal. So we just calculate this one by 5% of your nominal during the startup. Okay, so the single phase sensing, this is a single phase sensing. So this is only like one coil or one winding for that, so end to end of that. So you can take around only like 120 volts above. Okay, so parameters, voltage, stability, amps and hertz can be set with the terminal timers, and it is default to 56 AO. So it is applicable for 56 hertz through the jumper methods. So all the parameters can be programmed via software. Oh, okay, so you can also program this one via software. So the analogical remote controls of output voltage is possible through external voltage from 0 to 5 VDC with a 10 kilo ohms linear potentiometer. Okay, So we have the temperature, working temperature. This one is 25 degree to 70, and the underspade protections is adjustable thresholds at slope. So they have their graphs for this one, so you can relate from that. You can rely for that. So you can rely for that graphs or the slopes for that. Under excitations, alarms, loss excitation, it is from page 4. Okay, so here the under excitation, alarm, loss excitations. Okay, so here you can find it, this one in the page 4. Okay, as I told you. So now excitation over current protections with delay intervention. So they have some delay, this one. So you can, I think there is some adjustment there. Okay, I will show you if we are go through it. Management of the temporary short circuit startup to the synchronous motor. Okay, so non-isolated or open collector output signaling, the interventions of protections with the configurable activations for individual alarms. So okay, possibility to delay the interventions and selectable active level 4. So abnormal operations conditions, storage types, alarms, events, and durations of lasts, total time, blah 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 blah. Okay. So here is the terminal of your AVR. So we have here the 1 up to a 15 terminal. So here is the functions, that one, or the name for each of the numbers. So for example, this is the these are, so we have here the terminals. This is the terminals here. This is from 1 to 15. So in each of the terminals have the designated functions. So I will tell you what is the functions for that one. So number 1 is your negative connections for your exciter. So this is the negative, and the number 2 is your positive connections for your exciter. So excitations, continuous rating up to 5 ADC. As I told you, this is the maximum continuous for your if you see continuous, it is running your generator. So it is half at 5 amps DC. So transitory ratings is up to the maximum peak of 12 ADC. Okay, so this one is only like range for the split seconds only. So number 3 is your auxiliary auxiliary. Here is also excitations like this. So this is the auxiliary connections where you can connect your auxiliary winding. So this is from number 3. So number 9 is your auxiliary neutral connections, which is also this one. This kind of VBR is applicable for from 12 Hertz to 72 Hertz. It is range at 2 for TVC to 270 volt AC. Okay, so here is stated the sensing paces. You have here the 2 types of pace. You have the F and you have the H. So this is all about the sensing connections, where you can designate from the range of 140 to 280 VAC and 70 to 40 VAC. Okay, so it measures the average value rectified or actual effective via low for voltage adjustment. So okay, so we have the F and H. So this is different ranges of your voltage. So it is number here So F is from number 4, 5 also is from F phase sensing connections, and 6 and 7, this is the H, which is this is the 70 and for 140 VSC. So F is a little bit higher sensing, and H is the lower value range of sensing. So it also is your auxiliary neutral. So okay, so this is your auxiliary neutral, and we have also here the auxiliary neutral. So let's see the actual diagram for that one. So number 10 is your VEX PIX. What is this VEX PIX? Let's see in the. So this is 11 is your common connections, input from the remote voltage okay, connection. So 10 and 11, this is your external potentiometer. So this one you can apply your external voltage adjustment. So here 10 and 11, so this is the connections for your potentiometer. So input voltage for the remote voltage control. So this is also, I think, for your okay, not insulated, range up to 0, adjustment from the, this is the sensitivity for this one is around 14% to plus minus 14% and plus 14%. Okay, we have them square root of 3, so 0 to 2 milliamperes. Okay, it tolerates the voltage from 0 to 5 or negative 5, I mean, sorry, negative 5 to positive 5, but the value exceeding the range is automatically disabled. Oh, okay, so they have their own safety features. If you are exceed to 5 voltage, it will automatically not working. So it will automatically, is stated here, it is disabled itself. Okay, so here it is also number 12. This is the connections 12 and 13. This is the connections from your or to your 50-60 connections. Jumper input is 50-60. So I want to know if it is with jumper is 50 and without jumper is 60. Okay, so not insulated, maximum 3 meters. Selections of underspeed protections thresholds, 50 at 100% at 100% hertz, 60 at 100% hertz. Is positions relatively each hertz term. Okay, so this one is you have the hertz potentiometer where you can adjust. That is only the sensitivity for your hertz protections. Okay, so it is stated here. So our last connections here is the APO. So this APO and your common. So 14 and 15 is your connections for your jumper. This is only for the jumper. For your this is protections, I think. Yeah, active. Here is the meaning for that. Sorry for I'm searching a lot, but it is here in my face that it is active protections output. Okay, so this is non-insulated upper connections. So this is only the connector you are going to use. This one process programmable, active level, activating alarms or delay. Okay, so note that the terminals are connected to each other on the board with 2 and 3. Okay, 4 and 5, 6 and 7, 8 and 9, 11 and 13. Oops, I'm wrong. 8 and 9. So 11 with 13 and 15. Okay, so once again I will tell you once more. Terminals are connected to each other on the board. So 2 and 3 it is connected each other, 4 and 5 it is connected, and 6 and 7 it is connected to, 8 and 9 it is connected with 11 and 13, 15, it is connected. So note number 2, the external AMI filter. So AMI filter, so this is the SDR 128K. So this one is for the filtering if you have, I think, a lot of what is this, dirty frequencies and everything, so they can filter out this kind of what is this, the device. This is what they call the SDR 128K. So I will show you that later, and which continue. Note number 3, starting from the revision stance firmware, so you can update the firmware also. Note that is starting from 18 to this is all about the firmware. So here the volt calibrations, this function is to calibrate. So this is from 70 VC to 140 VC, from 142 to 80 VC. See the paragraph setting voltage. Stability calibration, dynamic response adjustment. Okay, this is only for your stability. If there is some hunting or whatever, the voltage fluctuations, I mean, here in the stability you can adjust voltage if you have some designated nominal. So here you can adjust directly, so you can get the maximum or the minimum amount what you need for your AVR output or the voltage output for your alternator. So here is the calibration protections. This is only for the protections for over and under frequency. So this by negative 20%, 50-60. So amps, this is the calibrations, excitation, current, protections. See the okay. So this amps is only the protections. For example, how much you can maximum you can give for this kind of VBR, so you can adjust that one, the range of protections. For example, you don't want to maximum around 12 here. That's how much the maximum current can run of this kind of VBR. Stated here the excitations. Here is this is the transitory rating. So it is 12 EDC. So you can less or you can put it maximum here from this current adjustment for that one. So it's over here. Okay, so this is the calibration excitation. This is only all of this one here, the hertz and the amps is for your protections. Okay, so as you can see here, this is their block diagrams as shown is here. So this is the interface, whatever. So this is only the block diagram, if you can see where it is connections here. So we don't need to the dimensions for that one. We go directly to our connections. So here I will show you our first connections, which is this one is alternator with 6 terminals output. This one is range up to 140 to 280 volt sensing. So here is our connections for that, and I will show you where you can connect. So this is only 6 lead connections, I mean 6 leads alternator output. So here is your connections for that. So one is our, as I told you, as I stated before, that one is our negative for excitations. As you can see here, if we go follow this, excitations is all connected from our exciter. So around here is your positive, which is connected to your terminal number 2. So number 3 here is stated here is Z2, so which is connections from your auxiliary winding. So here is the color yellow, and this one is green. Okay, so it is connected at number 5. Can we zoom it a little bit? Yeah, so here is 4, 5. So okay, so next for that is your voltage sensing. It is connected to your number 4, and this one is connected from your one coil or one winding. So this one is stated here is U1, okay, U1 and U2. This is one coil, and this is connected to number 9. So this is number 9. Okay, so as you can see here, as we zoom in more, okay, so I just want to show you exactly the number for that. So okay, so as you can see here clearly, so 1 and 2 is for your exciter connections, 3 and 5 is your auxiliary connections, which is designated what is this, the letter here at Z2 and Z1. This is your auxiliary connections. 1 and number 9 is your voltage sensing connections. So 10 and 11, as I told you, this one is your external potentiometer, and 12 and 13, which is your 50 and 60 connections. Okay, so I think that if you join the connections here, that is for 60, and if it is open, that is for 50 hertz. So this is 14 and 15 is your APO, as I told you, that one APO for the protections operations only. Okay, so this one is also configurable. You can do the calibrations, this one, through configurations, whatever you want to have this functionality. Okay, so oops. So here is our voltage adjustment, stability, hertz and amps. So hertz and amps is only for your protection side. If you want maximum or minimum protections for that one, so you can rotate it clockwise or anti-clockwise. Okay, so as I told you here, and this side is for your communications. Here you can inject that cable, or you can connect those cable, and for your USB. Okay, so I will jump back down here. So this is your connections for your 12 leads. As you can see here, so there is some I think differences. So okay, so this one is blue and yellow, which is blue is connected from your 1, which is negative from your exciter, and your yellow is your positive from your excited, which is connected, and number 2. So number 3 is Z2, which is your auxiliary winding. This is from 12 leads, and this is green, is it is connected from now, is changed to number 7. Yeah, this is now at number 7. Okay, so your voltage sensing here is changed to number 6. Okay, this is number 6, which is, as you can see, this is the verdigreen, and this is number 3 and 4, going to your number 9 connections. Okay, so as you can see here clearly, I want to zoom in more so you can see exactly the number. Okay, so 8 and number 6, 6 and number 9, that is your voltage sensing, and 7 and your 3 is for your auxiliary, and 1 and 2 is for your exciter. Okay, so by the way guys, so again, here is our connections for your 12 leads. So I'm done from it. So the same, everything is the same from your potentiometer, and it's 50-60 and your APO. So what is the difference down here from the rest of the connections is they have our for this one is for your paralleling connections. So if you need this AVR for the paralleling connections, and now you need this PD 500 for your droop functionality. So here is joint with your number. What is this? 1 2 3 1 and 2 3 or 4. So that is number 4, which is connected for your PD. Okay, so here is jumper. Here this is your terminal connections, and going out from your W1, this is one coil also going straight to your W2, and it is connected from your 9. So it's like it's just connected in series, this connection. So here also you can adjust your drop adjustment. Okay, so this application only is used for the paralleling. So you have the drop connections here or adjustment here. So next is this one is for the 6 leads terminal, and this one is for your 12 leads terminals connections. Okay, so same as the previous one, you have only the P in series with this PD in order to work your paralleling wiring or synchronizing. Okay, so if you see 12 leads, so just only vary the connections from the terminal, so you cannot it is different from your 12 and 6 lead connections. That is different. So just follow whatever the diagram here, so it is not make you struggling for that, or it will not make you mistaken for those connections, because maybe once you mistake, you just waste the AVR because it will burn. Just make sure that you follow all the connections and the wiring diagram for it, so you can be so it can be work properly as what you wanted. So here is your references for all the 12 leads and blah blah blah. So as here the connections comes, these are, this one is the APO, or this active potential. So okay, as stated here. Okay, so nothing, I told already for you this one. And here I have something different. What is that one I want to show you? We have here, so this is one also. You need this one if you need some filter for your to make it clean voltage output from your AVR. So you have to use this one, the SDR 182. This is only for the filtering for your functionality for your APO and everything. So it's here connected, this device. Okay, so here, as I told you, the communications from your laptop and from your AVR. So see it's linked from here, USB, and that is a 2.0 by 2.0. So it is connected from this side and to that device, so you can communicate through your laptop. So okay, that is the, I think, the important things you need to know in this AVR, that Meccalte have a different also numbering from their alternator, which is different from the Stamford and different from Leroy Sumer, their numbering. So they have their own numbering for their own alternator. So make sure that one, and rely always to the manual, so you will not be mistaken during the installations of this type of AVR. So as I told you now, that this DSR is also applicable for synchronizing. You need only this device for PD for your droop adjustment. Okay, and the last thing is this is also good EVR for the rest of the applications what you need. Okay, so guys, I will say thank you for our subscriber that we are reaching now, that to our 3,000 subscriber. I hope that we have a lot of people to know, and let's share also, so it will reach out to other new technical people or new fresh graduates people who are doing the technical job also, so they will learn also. Maybe they can learn a little things from these vlogs also. Help me to grow more to our channel, so we can help more for the rest of the technical there, which is seeking also for help. So thank you for our 3,000 subscriber, and once again, if you need some questions and if you have some doubts, and don't forget to comment down to our YouTube channel, and those who are not yet subscribed, just subscribe now so we can do more to our topic. So once again, benzblogs is here. See you again in my next vlog. Bye bye.